So let's go over this homework here. This is 4.3a, geometric sequences. And remember the difference between a sequence and a sum. A sequence is just you have a list of numbers, right? 1, 2, 3, 4. A sum is when you add them all up together. So a sequence is just a list of numbers, and a sequence is a list, and a series is when you add up together. Add a list. So we're going to talk about geometric series or sums today. So with the geometric sequence, we have a few formulas we need to remember. And again, we'll go over these formulas more on Friday, but quickly, we have the general formula, general geometric formula, which will tell us the pattern of numbers for any value a sub n. And the equation was we take the first number times some common ratio to the power of n minus 1. R is our common ratio. Let me do them blue. Common ratio. It's the thing you multiply by every time. What are you multiplying by every time? That's your common ratio. And of course, A1 is the starting number. A1, we said this is the starting number. Our first number in the sequence, right? A sub 1, our beginning number. We had a couple other formulas we used to find R, to find the R value. It was the difference between the equations, right? It was so it was not that it was the division between the two numbers. So if you have two numbers in any particular order, even if they're not next to each other, you do this sort of pattern to find this R value. You take a sub m, one term that you know, divided by the other term you know, always going backwards, and you take this to a fraction exponent to the power of 1 over m minus n. So to find R, we have this formula here. It's am and an. These are any particular values in the sequence. It could be the second and third terms, or second and third, right? And 2 minus 1 is have a power of 1, which is just divide the two. It could be the fifth term and the ninth term. So 9 on top, 5 on the bottom, and you'd have to the power of 1 over 9 minus 5, which is 1 over 4. And you would plug that into a calculator, and you'd get the answer. So you have this fraction exponent. You're going to have to do this in a calculator sometimes. So again, you're going to need to use that either Calculator x84 app, or you're going to need a graphing calculator that you can use, something that you can use to do fraction exponents. And I'm going to show you how to do that again later today. You also have the ability to find the first term, a1. And we know that a1 is equal to a sub n divided by r to the n minus 1. It's basically this same formula here, except we solve for the first term. So we divide both sides by this r, move it over here. Divide by this r, move it over here, right? We have a1. The first term is any particular number. Let's say I know the 12th term, a sub 12. I would do the 12th term divided by the common ratio to the power of 12 minus 1. If I had the 5th term, I would do the 5th term divided by the common ratio to the power of 5 minus 1. So whatever number I have, I use that to find the first term. Basically, I'm going backwards that many times. I'm dividing that many times by the common ratio. Instead of multiplying, I'm dividing. So we have these formulas, but again, all of this you can use what's called simple brute force math. Because it is a common pattern, you can just count out the number of terms, figure out the spacing, multiply a bunch of times, divide a bunch of times, whatever you need to do to figure out this pattern. Easiest way The hardest thing is probably finding r, and you have this easy formula here to use to find the common ratio. Once you find that ratio, everything else is pretty simple. So these were the equations we had for geometric equations, for geometric sequences. And we used these equations in the homework on Friday. So what did we do? Let me box these equations here. Our key equations, this general formula, equation to find r here, make sure we have that, and the equation to find a1. 3 key equations in geometric sequences. So in the homework, I had you do, what did I say, numbers 1 to 17 odd, 25 to 35 odd, right? 25 to 35? So were there any questions in that particular grouping of problems that people would like me to go over from the homework? Or should I pick a couple and show you how to do them? All of 25 to 35. All right, we can pick a couple from there. Let's do number 25. Maybe do 25, and maybe I can do 27. Pretty easy. And maybe 33. So that section, we got that section covered. Any of the beginning section problems? One to 17, you create your formulas, determine if it's arithmetic or not, geometric or not, find the equation. Maybe we'll do number 11. So I'll pick a couple from these sections, do these problems here, and we'll show you what I mean by using these formulas to find geometric sequences. So let's start with number 11. This says find the first 5 terms of the geometric sequence. We're telling you it's geometric, so you don't need to worry about it. And we give you some information about the geometric sequence. We know it's geometric, and we know that A1, in number 11, it tells you that A1 is 6, our first number in the sequence is 6, and it tells us that the common ratio is 3. So it tells us this information about the geometric sequence. How do we use this information to write the first 5 terms? Well, anytime we have to write an equation for a sequence, arithmetic or geometric, you always need 2 pieces of information. You need to know what is the first number in the pattern, where do we start, and you need to know how does the sequence change. What's the common difference or what's the common ratio? You need those 2 pieces of information. What's the starting number and how do we change? And so for this number 11, they give us both those pieces of information. They give us the first term is 6. They tell us that the common ratio is 3. So if I was to do brute force, I want the first 5 terms. So I want n is 1, 2, 3, 4, and 5. Well, I know that my first number is 6. My second number, I just times it by 3. And that's going to be 18. Right? And then I times it by 3 again. And that's going to give me the next number. On and on and on and on and on, right? I don't know what 18 times 3 is. This is where we bust out the calculator. 18 times 3, that's going to be, what is that? 54 times 3 again. 54 times 3. 54 times 3 is 162. And then 162 times 3 is 486. And there's our answer. first 5 terms of the sequence laid out in a pattern here. 6, 18, 54, 162, 486. Because we knew it was geometric, geometric means multiply each time. Multiply each time. And so we did that multiplication each time, and we got our answer. Multiply each time. The other way we could have done this is use a formula. I know that A1 is 6, R is 3, so I could have written my formula A sub n is 6 times 3 to the power of n minus 1. This formula here I could use to generate these numbers. If I plug in a 3, it'd be 6 times 3 to the power of 3 minus 1, which is 2. If I had that fourth term, 6 times 3 to the power of 4 minus 1. So I plug in my numbers here and get my pattern at the 6 here and the 3 here coming from the first term and the common ratio. So that's it. You find the first 5 terms, use your pattern, multiply each time. It's a geometric sequence. Geometric means multiply. What if it's a little more complicated, though? This one was easy. It gave us the 2 numbers that we needed immediately. 25 is a little more complicated. 25 tells us, again, I want the nth term here. It tells us that A1 is 4, and it tells us A4 is a half. And it wants the 10th term. Okay, so I got the first term, I had the first term here, I got the fourth term here. I need the 10th term. I need to know, and I'm told it's a geometric sequence. I'm told this is geometric. I know that it's going to be a multiplying by something every time. How do I figure out what it is I'm multiplying by every time? I've gone from the first term to the fourth term. I don't know what A2 is or A3 is. I don't know what the middle pieces are. So I don't know necessarily. It's hard to tell when I jump from each piece to piece. It's hard to know how I get here. So the key question here is, what is R? This is the first question you want to ask yourself for any geometric sequence. What is our ratio? What is the thing we're multiplying by? And thankfully we have a formula. This formula here for R. To find R, take R is equal to take the one of the terms you have, the later term, divided by the earlier term to the power of 1 over the distance between m minus n. So for R here, R is am over an to the power of 1 over m minus n. For me, this is going to be m is going to be this one, the later one, and n is going to be this one, the earlier one. So I'm always dividing, you're always dividing the later one divided by the earlier one. You always go backwards. Always go backwards in this process. This is m is the later one, n is the earlier one. So I would say, all right, this is 1/2 divided by 4 to the power of 1 over, later one is 4, minus, this one is a 1. And I would take this straight into a calculator. It's going to give you a crazy decimal, so maybe it's not as easy as that. If I were to simplify this, let's see, 1/2 over 4. Well, I don't like it when fractions over a fraction, right? How do I fix that? Normally I take the bottom number and I do a little flip-a-do, right? But this bottom is not a fraction. Or is it? Any number is a fraction, everybody. 4 is 4 over 1. So I can take this as really 1/2 times 1 over 4 to the 1 over 3. which is going to be 1 over 8 to the power of 1/3. And if you plug that into a calculator, you're going to get 1/2. Mr. Mitchell, how did you do that? How do you know? Well, I remember that 1/3 power, remember that fraction exponents, if I have a to the 1 over n, it's the same thing as the nth root of a, right? Fraction exponents are radicals. So 1 over 8 to the 1/3 is the same as 1 over 8 to the 1/3 power is the same as the cube root of 1 over 8. And I know that, well, if I do a radical of a fraction, I just do each one by itself. Cube root of 1 is 1. Cube root of 8, I know that's a 2. Right? With the radical of a fraction, you just do each piece separately. Give each piece the radical. So cube root of 1 is 1. Cube root of 8, I know is 2, so that's a 1/2. 8 to the 1/3 power. 1/3 of 8, and that's 1/2. So this kind of math is stuff that... Speaking of mosquitoes, everybody. This kind of math is stuff that, if you're not sure how to do it, plug it into a calculator. And this is my R value. This is my ratio. So I know that I'm multiplying every time by a half. Great. So I know my R value. What do I want to find? I want to find the 10th term. So I have the R value. I know what I am multiplying by every time. My most important thing. The most important thing you want to know first is what are you multiplying by? What is your R? Once you know that, everything is easy. Because if I want the 10th term, I have the 4th one. I can just do a bunch of multiplications. If I'm on number 4, take the 1/2, multiply by a half. That'll give me the 5th term. Then multiply by a half again. That'll give me the 6th. Then multiply 7, multiply 8, multiply 9, multiply 10. Multiply it 5 more times, and that would give me the 10th term. So 1/2 times half times half times half times half times half. You use a calculator, you'll get a very large fraction. If you don't like to do it brute force like that, nothing wrong with that, you can use our general formula. We know the general formula. General formula. How do I spell this? General formula. General formula. We have an is a1 times r to the n minus 1. Well, I know what a1 is. a1 is 4. I know what r is. It's 1/2. So if I take this equation, I'm going to get 4 times 1/2 to the n minus 1. And if I want the 10th term, okay, well, I'm going to plug in the 10. 4 times 1/2 to the 10 minus 1, which is 4 times 1/2 to the power of 9. Plug this into a calculator. You're going to get, let's see, 4 times 1 over 2 to the power of 9 is going to be 512. Right? It'll be 1 over 128. Let me write this answer a little bit bigger. Equals 1 over 128. And that is a sub 10. That is our 10th term. That's what we wanted to find. Whew, goodness. So using all these terms, using all this process here, we use this process to find the formula, find the 10th term, find the term we want. Or again, you can just do this brute force. You can just plug in the numbers, get the R value. The most important piece of this is this R value over here. Most important thing you need to figure out first. Once you get that, it's just a bunch of multiplication. It's just a bunch of multiplying. Take your term, you want the 10th one? Well, here we are on number 4. Multiply a bunch of times till you get to the 10th one. Or you can use our general formula and do it in the calculator this way. Okay? Questions, concerns about that? All right, so let me talk about our next topic then. We don't have time for the other questions, everybody. 33, yeah. The others are exactly the same. 27, 33, exactly the same as this. You just find the pattern, find the term you want. Okay? So let's talk about our next topic here. Geometric sequences. Let me get into that.